Hi students, now let's see the LR0 parsing. If you want to parse a string, that is a LR of 0, you need to follow some steps. So step by step procedure. First what you have to take, first the input whatever they are given. So let's see the steps, you will understand. Now the concept is LR0 parsing. Okay, that is the first one in LR parser. LR0, SLR1, LA, LR1, CLR1. So these are the different algorithms which we used for call as LR parsers. So in the previous video I explained what exactly the LR parser was. Now let's see what is LR0. So to construct LR0 parsing string, you need to follow the steps. The first step is, for the given input string, write the context-free grammar. The first thing is you have to, whatever the grammar that they are given, you have to check whether it is a context-free grammar or not. Next, check the ambiguity of a grammar. If there is any ambiguity in the grammar, try to remove the ambiguity. Means if one or more is going to be generated, the trees, its ambiguity is there, just remove the ambiguity of that grammar. After that, add argument production in the given grammar. Okay, what is argument? Don't be confused, I'll explain that. Okay, up to here you know that. First the input string is there, for that input string write the context free grammar and check the ambiguity is there in that grammar. Next, add argument production in the given grammar. Argument production means, let's take G is a grammar. So here you can see this is a grammar. So if G is a grammar, the argument grammar G will be generated if we add one more production in the given grammar. So this here you are having 1, 2, 3. 3 productions are there. Okay. So that means S tends to A, S tends to A, sorry, A determines A and A produces B. So total there are 3 productions. Then argument grammar means, let's take G will be generated. If we add one more production in the given grammar G, it helps the parser. Means I want to add one more grammar here. If I add one more grammar, that is one more production. Okay, let's take S dash and determines S. Okay, so I just added one more production. So then what is the use of this production? Why making, whenever you add one more production, you call it as an argument grammar. Argument production. So this thing is the argument production. So why I am adding the argument production in the given grammar? So if you do this, it helps the parser to identify. It helps the parser. Okay, that is the LR0 parser. It helps the LR0 parser to identify when to stop the parsing and announcing the acceptance of input. So if you use this argument grammar, argument production, this argument production is going to help you to identify when to stop the parser. Okay, and announce the acceptance of a string. Okay, so that is just simply add one more production. S dash tends to S. S dash determines S. Okay, after adding the first check write context free grammar and check the ambiguity. Next, add augmented production. Create a canonical collection of LR0 items. I said in the previous video. Okay, first thing is you need to create a collection of canonical LR0 items. LR0 items you need to find out. Okay, so after finding out the canonical collection of LR0 items and draw a data flow diagram for that items. So whatever the items that you have taken for the items, you need to draw the data flow diagrams. And finally construct the parsing table. Okay, so after constructing the parsing table, still you need to, if you want to parse the input string, by seeing the parsing table, you just need to construct the input string, that is a stack implementation. Finally, the tree diagram. Okay, so let's take this example to construct the LR0 parsing. So this is a given grammar. S determines AA and A is determines AA/B. Okay, so this is a context free grammar and here there is no ambiguity is there. Now I need to add, the third step I need to add is add augmented production. Okay, So here I added the argument production, that is, this is the extra production. So this is a given grammar. This is the given grammar. For this grammar, I added the augmented production. So next what I had to do? The next step is I had to create a canonical collection of LR0 items. So how you are going to create a canonical collection of LR0 items? An LR0 items is a popular, is a production G. Sorry. An LR0 items is a production G with dot at some position on the right hand side of the production. So the canonical collection of items are nothing but any production if you are taken. Let's take augmented. LR0 item is a production G with dot at some position. So the dot should be at some position on the right hand side of the production. So here dot should be there. Then this is LR0 item. If dot is there, after dot, the right hand should be a non-terminal. And see the second point. LR0 items is useful to indicate that how much of the input has been scanned up to a given point in the process of parsing. Everyone will get a doubt. Why we are using LR0 items? Just placing a dot in the right hand side production. Just I am placing a dot in the right hand side production. So these are all becomes the, so whenever a dot is there, so after a dot, if the terminal symbol is there, means a closure of S, this you call it as a closure. The closure of S has to be generated. So generate, again S tends to dot AA. So again after the dot a non-terminal is there, then you need to find the closure of, you need to expand the complete productions of that closure. So dot A means again A tends to dot AA slash dot B. But after the dot there is only the terminal symbols are there. There is no non-terminal. Okay. Then you no need to extend the productions. You no need to write the productions because dot A terminals have no productions. Only the non-terminals will have the production. So whatever the productions that are produced by the non-terminal after the dot, for those productions you need to write with a dot 1. So now see why we are using the dot. So the LR0 item, these are all the LR0 items. The LR0 item is useful to indicate that how much of the input has been scanned. So for each and every step the scan is moving to the right hand side. The dot, the scan is doing the right hand side, the scan will be moving. So it's the rightmost derivative. So whenever here the dot is useful to indicate that how much of the input has been scanned up to a given point in the process of parsing. So in LR0 we place a reducer node in entire row. So whenever if you reach the last, if the dot is moved to the rightmost, if there is no terminal or non-terminal is there, okay, then you can say it is a, we place a reduce node in entire row. So don't be confused if you take the example. So this is an example. Whenever you are constructing the, drawing the DFD diagram and constructing the table, it will be clear for you. Okay. So, okay, creating canonical collection. So next what? Next is I have to draw a data flow diagram. So with the help of the canonical collection items, means the LR0 items, I am going to draw the data flow DFA diagram. Okay, so these are all the steps to follow. For each and every state I have taken I0, I1, I2 different states. Now let's see the drawing of canonical, by using the canonical items. Let's draw DFA diagram, data flow diagram. So this is the canonical items, LR0 items, canonical collection of LR0 items. S dash determines dot S determines dot AA, and H determines dot AA slash dot B. Okay, so this state you call it as I0. Let me take the pen. This state you call it as I0. Okay, now let's take first one, S determines dot S. So going on S, I am moving from state 0 to state 1, that is a I1. So whenever there is a dot here in the right hand side here, you just move the dot to left hand side. Okay, so on S, S dash determines S dot. This is I1 state. Okay, so S is over. What is the next non-terminal? Next is A. So if you want, you just write, if there is, suppose here dot is there, still you need to write the productions for that, because whatever the production that non-terminal consisting of, you need to write all the productions. But here S dot means after dot there is no non-terminal is there. So you just stop this state here itself. I1 you need stop here. Now let's take the A. Okay, so S, the production on A, the non-terminal A. Now coming to state I2. So S determines, just move the dot to the right hand side. A dot A. A dot A means after dot there is a non-terminal A. So again write whatever the productions that are present for this non-terminal. So still A consisting of dot A slash dot B. So I had written that production also. Okay, so after dot A means for terminals there is no productions. Okay, so I2 is over. Now coming to the I3. So S is over, terminal A is over, non-terminal S and A are over, and still the remaining elements are the terminals A and B. Now let's see that on A. On A, the production was A determines, just move the dot from left hand side to right hand side. It becomes A dot A. So dot A is still a non-terminal. So non-terminal means you have to write the productions that are available for A. So what are the productions that are available for A? A determines dot A and A determines dot B. Okay, so you need to write that productions also. I3 is over. Now for the remaining element is B. So in I0 state, what are the inputs? The inputs are S, the non-terminal, A non-terminal, terminal A, and B is the terminal. So I am returning all the inputs that are present for the I0 state. And B. So the B having the production A dot B. So just move the dot to right hand side. This is I4. So up to it is clear. Now coming to again the starting. So here there are no states produced because S dot, after dot there is no terminal and non-terminal is there. So you just drop the state. And now coming to I2. I2 is the first production on A. S determines A dot A. A dot A. So on A, you just move this dot to right hand side. Then I5 becomes S determines A dot. So A dot. So after dot there is no production, means no non-terminal is there. So you can stop this production here. You can stop this state here. Next coming to here. Okay. So still here A determines dot A dot B. Because here dot A, if you see A, the production or the input is A. If the input is A, it becomes A dot A. A dot A is already written in I3. If it is already written in I3, then just shift into that I3. Just shift into that I3. Okay. And now coming to dot B. Okay. On B, A determines B dot. It will come A determines B dot. So the A determines B dot is already in I4. So just shift into that I4 B. Now coming to I3 state. So I3 state, A determines A dot A. So if you take A as an input, okay, so the dot is moving to right hand side. The dot is moving to right hand side. So just take A as an input for I3. The dot is moving to the right hand side. It becomes I6 state. A determines A dot. A dot is not here. So I had taken another new state. Now coming to A. Next one. A determines dot AA. On A, it becomes, when I move the dot here, A dot A. A dot A is already in this state only. Just shift in A into this state only. Next is A determine dot B. On B, if the input I had taken as a B, it becomes A determines B dot. So just move into B dot. Okay. So now I completed all the states. So this is a data flow diagram. So don't be confused. Just take a paper and try to draw your own. By seeing this example, just take what is the first state and what is that inputs that are present in that first state, S, A, B. Try to construct the next state that is going to be generated. Because I have to shift the dot, the LR0 item is going to shift the dot to the right hand side. If it becomes to the right hand side completely, let's check here. The dot comes to the complete right hand side. So until the dot shifted to complete right hand side, if there is no terminal or non-terminal is present, then you visited all the variables, that is the terminals and non-terminals. So that is the concept here. Okay, so for each and every state you need to check what are the inputs that are present. Still here, after dot, whatever the element that is present, that is an input. So after dot, still A is there, so A becomes input, and after dot small a is there, then A is the input. After dot, small b is there, so small b is the input. Okay, so this is the data flow diagram. So in the next video, I'll explain how to construct a table for this data flow diagram. So still the LR0 construction is pending. So watch in the next video. Thank you.